Is it screen is visible?
Yes, sir.
Yes, sir.
Okay. So in the previous lecture, we seen that if R is the unique factorization domain, then any polynomial P of x belongs to R of x with a primitive polynomial in R of x, then P of x can be factored into unique way as a product of irreducible elements in R of x. Okay. So today, the next point is if R is unique factorization domain. Okay, if R is unique factorization domain, it implies R of x is unique factorization domain. Okay, so next theorem is if R is unique factorization domain. Okay, if R is unique factorization domain, it implies R of x is unique factorization domain. Okay, we have to prove this one. Proof. Let f of x belongs to that R of x ring of polynomial be non-zero non-unit. Non-zero non-unit element in R of x. Okay, we have to prove that this R of x is unique factorization domain. Okay, so it satisfies two conditions. If taking any polynomial in R of x be a non-zero and non-unit element, so we have to prove that the first condition. What is the first condition of unique factorization domain? UFD. So every non-zero non-unit element we can write in the form of product of irreducible elements. Okay, and that representation is unique up to associates. Okay, so I have taken f of x, any arbitrary polynomial in R of x, be a non-zero and non-unit element in R of x. Okay, so let this f of x we can write in the form of c into p of x, where c is what? Content of f. Okay, that is f of x, and the p of x is reply that either. Okay, p of x is primitive polynomial in R of x. Okay, any doubt up to here?
No, sir.
Okay, so hence if q of x, okay, here p of x is the primitive polynomial by previous theorem, we can write any primitive polynomial in the form of irreducible element in R of x. So by previous theorem, p of x we can write in the form of q1 of x into q2 of x into q3 of x up to so on. This is qn of x. Okay, where all qi is qi of x. Okay, is an irreducible element. Irreducible element in R of x. Okay, hence this representation is unique up to associates. We proved in the previous lecture. Okay, yesterday lecture. So this representation is unique up to associates. What is the meaning of this sentence? If one another representation is there, then that representation is cancel पाहिजे त्यातले. If suppose p of x is equal to r1 of x, r2 of x, and up to rn of x is one more representation of p of x, then that qi is associated to rj for some I and j. Okay, so this representation is unique up to associates. Also, we have, okay, also we have c. the content C belongs to R. Okay, and R is what? Unique factorization domain, which is given to us. That implies first condition काय असेल, एक तर सी काय असेल तुमचा युनिट मेंबर असेल किंवा सी हा नॉन युनिट असेल. ओके, इफ सपोज फर्स्ट कंडिशन इफ सी इज युनिट इन आर. ओके, और सेकंड कंडिशन काय असेल, सी is non-unit in R. That implies C can be expressed. C can be expressed as C is equal to C1 into C2 up to Ck. Okay, where Cr is irreducible elements in R. Okay, by the definition of unique factorization, C belongs to this R, but R is unique factorization domain. Okay, जर C unit असेल तर काहीच करायची गरज नाही आपल्याला. If C is non-unit, then C can be expressed as C1 into C2 into up to Ck. Okay, where all the C are irreducible element in R for all R, and R running from 1 to K. Okay, by definition of unique factorization domain. Okay, now case 1. If C is unit in R. Case 1. Okay, if C is unit in R. Okay, what happens if C is unit in R? Then f of x is equal to C into P of x. Okay, which is equal to C into, what is the value of P? Q1 of x into Q2 of x up to so on Qn of x. Okay, which implies C into Q1 of x. Okay, into Q2 of x up to so on Qn of x. Okay, which implies, which is equal to, this Q1 is irreducible, this Q2 is irreducible, all the Qi's are irreducible, and C is unit in R. So C into Q1 is also irreducible element. So which is equal to finite product of irreducibles. Okay, so this is the finite product of irreducible elements in R of x, and the representation is unique. The representation is unique up to associate. Okay, any doubt up to here?
No, sir.
If C is unit, then C into Q1 is also irreducible. Okay, if Q1 is irreducible element and C is unit element, so C into Q1 of x काय असेल हा तुमचा irreducible असेल. For example, x square plus 1, which is belong to R of x, which is equal to समजा this I of x आहे. Okay, so ह्याच्यातला युनिट काय कोण आहे? -1 -1 किंवा 1. So minus x square into -1 is also irreducible element in I of x. Okay, if you taking +1, so you get x square plus 1. So x square plus 1 in 1 into x square plus 1 is also irreducible element. Okay, so hence f of x is the finite product of irreducible elements in R of x, and this representation is unique. Hence R of x is unique factorization domain in case 1 if C is unit element in R. Okay, now case 2. We have to prove that the R of x is unique factorization domain. Okay, in the second case, if C is non-unit, if C is non-unit in R. Okay, then we can write the C is equal to C1 into C2 up to Ck. Okay, where each Ci is an irreducible. Okay, by the definition of unique factorization domain, these all the Ci's are irreducible element in R. Why? Because since R is unique factorization domain. Okay, so in unique factorization domain, any non-zero, non-element, non-unit element we can write in the form of product of irreducible elements. Okay, so C is equal to C1 into C2 into up to Ck. As Ci is an irreducible element, in R, it implies Ci is an irreducible element in R of X. Why? Because R is contained in what? R of X. Okay. So Ci is an irreducible element in R of X. Thus, we can write f of X is equal to C1. Instead of C, we can write C1 into C2 up to Ck into U1 of X, U2 of X, X. Okay, now look at here. This C1 is irreducible. This up to Ck all are irreducible element in R of X. This Q1 is also irreducible element in R of X. Up to so on, this Qn is also irreducible element in R of X. Okay, so therefore, f of X is equal to finite product of irreducible element in R of X, and the representation is unique. It's unique up to associates. Okay, so thus both in both the cases, that is if C is unit and non-unit, thus in both cases, which one? If C is unit and non-unit. Okay, both the condition, both the both condition of unique factorization domain. Okay, the two conditions of unique factorization domain are satisfied. Okay, so we get that R of X is unique factorization domain. Okay, so thus R is unique factorization domain, it implies R of X is unique factorization domain. Okay, any doubt?
No, sir.
For example, Z is unique factorization domain, which implies Z of X is unique factorization domain. Okay, any doubt up to here?
No, sir.
Okay, and the next theorem is if let next theorem. Okay. Let capital F be a field Let capital F be a field and let f of x belongs to capital F of x. Okay, that is ring of polynomial. Okay, here f is the field, then f of x is what? Field of the integral domain. काय असेल? हा रिप्लाय द्या काहीतरी.
Integral domain.
इंटिग्रल डोमेन असेल. ओके, एफ ऑफ एक्स हा फील्ड नसेल कधीच. ओके, लेट the degree of f of x is either 2 or 3. Okay, समजा the degree of f of x 2 किंवा 3 असेल, then f of x is reducible over f if and only if f of x has a 0 in f. Okay, what is the theorem? If let f be the field and f of x belongs to this capital F of x, okay, a small f of x belongs to capital F of x, and let the degree of f of x either 2 or 3, then f of x is reducible over f only if, okay, this is capital F, if and only if a 0 in capital F. F. Look at the proof now. Only if part. Let this f of x is reducible. Okay. If f of reducible and the degree of f of x is given that 2 or 3. Okay. Reducible over f. Okay. And degree of f of x is 2 or 3. Then to prove that f of x has a 0 in f. Okay. Now look, if f is reducible over f, so what is the meaning of this sentence? Then f of x we can write in the form of g of x into h of x. Okay, where this g of x and h of x belongs to capital F of x, that is ring of polynomial, such that 0 less than degree of g of x is less than degree of f of x. Okay, 0 is less than degree of h of x less than degree of f of x. Okay, any doubt?
No, sir.
Okay. No, sir. Implies that degree of f of x, sorry, small f of x, small f of x is equal to degree of g of x plus degree of h of x. Why? Because this f of x is integral domain. Integral domain असताना काय असते? h degree is equal to degree of f of x is equal to degree of g of x plus degree of h of x when this f of x is the integral domain. ओके, तुमचा इथं हा f हा फील्ड आहे म्हणजे काय झाला तुमचा कॅपिटल f of x हा इंटिग्रल डोमेन झाला. जर इंटिग्रल डोमेन नसता तर काय असता?
Less
h
equal.
असते. सो इथे काय असलं असतं मग लेस दॅन ऑर इक्वल टू. ओके, so here the degree of f of x is equal to degree of g of x plus degree of h of x. Why? Since f is field. Okay, field म्हणजे काय तो f हा तुमचा काय इंटिग्रल डोमेन. Okay, now x degree of which is given to us, okay, is equal to 2 or 3. Okay, नीट लक्ष द्या आता काय. समजा degree of f of x is equal to 2 or 3. So what it implies? Degree of g of x is equal to 1 or degree of h of x is equal to 1. या दोघांमध्ये पडले तर ह्याची डिग्री जर 3 असेल, ओके, तर पॉसिबिलिटीज काय आहेत? ह्याची 2 असेल किंवा ह्याची 1 असेल किंवा याची 1 असेल याची 2 असेल. ओके, ह्या 2 पॉसिबिलिटीज. समजा डिग्री ऑफ एफ ऑफ एक्स 2 असेल तर काय पॉसिबिलिटी? याची 1 असेल आणि याची 1 असेल. ओके, so if degree of f of x is either 2 or 3, at least one of them, g of x or h of x, must be the degree of g of x is equal to 1 or degree of h of x is equal to 1. दोघांमधला एक तरी काय पाहिजे? डिग्री ॲटलिस्ट 1 असायलाच पाहिजे. ओके, पहा पॉसिबिलिटी. जर 2 असेल तर दोघांची 1 1 होईल. 3 असेल तर ह्याची 2 असेल, ह्याची 1 असेल. ओके, आणि अजून एक पॉसिबिलिटी काय? ह्याची 1 किंवा ह्याची 2. Okay, as degree of f of x is equal to 2 or 3, it implies degree of g of x is equal to 1 or degree of h of x is equal to 1. Okay, any doubt?
No, sir.
No, sir.
No, sir.
Is the reason at least one of the polynomial in either case, okay, is of degree 1. Okay, so let us assume the degree of g of x is 1 असेल. Let us assume the degree of g of x is equal to 1. So what is the nature of g of x then? Then g of x is equal to काय असेल? x minus a. Okay, okay, या फॉर्म मध्ये असेल. Say for some a belongs to f. तुम्ही म्हणसाल x minus is का? x plus a का नाही? ओके, मला a ची व्हॅल्यू माहित नाही काय. That's why we are taking in general x minus a. ओके, प्लस हे असू शकेल, x प्लस पण असू शकेल. जर x प्लस a असेल तर a जर मी मायनस घेतला तर काय होईल? मग x minus a होईल. ओके, so then the degree of g of x is 1, then g of x is equal to x minus a for some a belongs to f. Then what is f of x then? F of x is equal to x minus a into h of x. Okay, so it implies f of a is equal to a minus a into h of a, which is equal to 0. Okay, that implies a will be a 0 of f of x belongs to that capital F of x. Okay, तुम्ही म्हणताल मग इथे g of x का घेतला, h of x का नाही घेतला? मग h of x घेतला तर इथं काय येईल? मग इथे h g येईल. मग ओके, इथं काय येईल? मग h. ओके, g च्या ठिकाणी h येईल, h च्या ठिकाणी काय येईल? g होईल. ओके, एनी डाउट in the first part?
No, sir.
No, sir.
Okay.
No, sir.
Now the second part, if part. If small f of x, okay, belongs to this capital F of x, has 0 in f, say a. Okay, f of x belongs to capital F of x, has a 0 in f, say a, then we have x minus a is factor of f of x. Okay, hence we can write f of x is equal to x minus a into g of x. Okay, hence degree of f of x is equal to degree of x minus a plus degree of g of x. Okay, where g of x belongs to Kyle, that capital F of x. Okay, now if degree of f of x is equal to 3, then degree of g of x Kyle, what is the degree of g of x then?
2.
2. If degree of f of x is equal to 2, then degree of g of x is
1.
1.
as the degree of x minus a is equal to what? 1. Okay, so in the both the cases, we have implies 0 less than degree of g of x less than degree of f of x. बघा या बोध केसमध्ये जर 3 असेल तर काय होईल? डिग्री ऑफ g of x 2 येते. 2 असेल तर काय होईल? 1 येते. Okay, so it implies 0 greater than less than degree of g of x is less than degree of f of x. Okay? Okay, any doubt?
No, sir.
No, sir.
And what is the g of x here? The h of x काय येईल तुमचा? x minus a. Okay, and also 0 less than degree of x minus a is less than degree of f of x. Okay, thus in either case, that is in the both the cases, f of x belongs to that capital F of x is an reducible polynomial in or in f of x, sorry, in f असेल किंवा over f असेल only. Okay, in f of x and over f, both the meaning is same. Okay, so this is the theorem we proved. Okay, if f of x has a 0 in f, then f of x is reducible over f. Okay, any doubt?
No, sir.
No, sir.
Now the next theorem is let f of x belongs to that capital F of x. Okay, be any polynomial. Okay, of degree greater than 1. Greater than 1. Okay, if the small a belongs to f is a 0 of f of x in capital F, then small f of x is reducible, okay, over f. Okay, छोटा है थेरम हाँ, proof खूब छोटा है. Okay, let f of x belongs to capital F of x with the any polynomial of degree greater than 1 and a belongs to capital F has a 0 of f of x in f, then f of x is reducible over f. Okay, so proof as fx and that x minus a. Okay, this is the polynomial. One more polynomial is here. Okay, are in capital F of x. Okay, so we have a is the 0 of f of x in f. So thus we can write that f of x is equal to x minus a into g of x. Okay, where this g of x also belongs to that capital F of x. Okay, therefore the degree of f of x is equal to degree of x minus a plus degree of g of x. Why? Because f is the field. Okay, which implies degree of f of x is equal to, what is the degree of this one is 1 plus degree of g of x. Okay, therefore, as degree of f of x. Okay, what is given to us? Degree of f of x is greater than 1. Hmm. That implies the degree of g of x काय येईल? The degree of g of x is greater than
1.
0.
1.
0 0 greater than 1
3.
असेल तर हा 2 असेल. 2 minus 1 किती येईल इथे? 1 येईल ना? Greater than 0.
Yes, sir.
Okay, greater equal by 1 येईल. ओके, कळते का?
हो सर.
Yes, sir.
हां, काही का असेल आपण डिग्री काय असेल? ग्रेटर दॅन 0. ओके, thus g of x is a non-constant. Okay, degree is greater than 0 झाली तर काय झालं हा? Thus degree of the g of x is non-constant polynomial. Okay, thus fx can be factorized into hmm, factorized into two non-constant polynomial, two non-constant polynomials. That implies f of x is reducible over f. Okay, any doubt?
No, sir.
No, sir. No, sir.
Let f of x belongs to capital of x with any polynomial of degree greater than 1 and a belongs to f is a 0 of f of x in f, then f of x is reducible. ओके, हां, मी मागच्या वेळेला एक क्वेश्चन सांगितला होता. There exist at most two ideals for any field. ओके, तर f हा माझा जर field असेल, okay, so there exist only how many ideals? Two ideals. Okay, which one? The null ideal
Singleton.
itself, null ideal and itself f. ओके, हे दोनच आयडियल कोणत्याही फील्डला असतात. तो स्वतः एक आयडियल असतो आणि हा सिंगलटन 0, दॅट इज नल आयडियल. ओके, समजा एखादा प्रॉपर आयडियल एक्स एस हा एक प्रॉपर आयडियल आहे कोणाचा? एफचा. तर तो काय असेल? आधी सबसेट असेल, ॲडिटिव्ह सबग्रुप असेल. ओके, समजा मी एखादा एलिमेंट एस मधून घेतला आणि आर मधून मी एफ घेतलाय, सो ए इंटू आर माझा कशात जाईल? एस मध्ये जाईल. ओके, ही माझी काय आयडियलची डेफिनेशन. ओके, so this is the definition of ideal. If A belongs to S and R belongs to F, then A into R belongs to S. Okay, if S is ideal, that is proper ideal. Suppose this is okay. Proper ideals means what? S is not equal to 0, singleton 0, and not equal to F. Okay, so S is properly contained in F. Okay, now look at here. If there exists, okay, if possible, suppose. Now take the A which is belongs to S. Any element A belongs to F. Okay, so what is F here?
Field.
Field. Okay, so this is, suppose this is non-zero. A belongs to S and F is the field. Okay, so any non-zero element, there exists an inverse. Okay, for that element. So here 1 upon A belongs to F. Okay, therefore A into 1 upon A, which is equal to 1. Okay, suppose S is the ideal. What is the meaning of ideal then? That A into 1 upon A, that is equal to 1, which belongs to yes. Okay, suppose any multiplicative identity belongs to yes. जर एखाद्या आयडियल मध्ये 1 हा युनिटी एलिमेंट मल्टिप्लिकेटिव्ह आयडेंटिटी जर त्या आयडियल मध्ये गेला तर तो काय होतो? S इज इक्वल टू F. Okay, nahi? How?
Yes, sir.
So suppose 1 belongs to S and A is the any element that belongs to F, then 1 into A, which is equal to A. This belongs to, yes, this is the definition of ideal. Okay, so here we get if A belongs to F, it implies A belongs to yes. What it implies?
Yes is equal
F
to F.
is the subset of yes. ओके एखादा ए मधला एलिमेंट घेतला आणि तो जातोय कशात येस मध्ये जातो सो एफ इज द सबसेट ऑफ येस बट वी नो दॅट येस इज द properly contained in F. So from these two condition, F must be equal to yes. म्हणजे एखाद्या फील्डला कोणताही फील्ड असू दे त्याला किती आयडियल्स एक्झिस्ट होतात ऍटलिस्ट नाही ऍटमोस्ट जास्तीत जास्त दोनच आयडियल एक तर तो नल आयडियल असला पाहिजे और इटसेल्फ ओके
Okay, sir.
wait a minute okay some remarks are there remarks if suppose we know that Z is the what principal ideal domain okay so every ideal is generated by single element okay suppose 2 प्रत्येक आयडियल हा कशा कोणत्या फॉर्म मध्ये असतो एव्हरी आयडियल इज इन द फॉर्म ऑफ दिस फॉर्म व्हिच इज इक्वल टू 2z okay set of all even integers 3z okay generated by 3 4z okay generated by 4 means what 4z प्रत्येक आयडियल हा कसा असतो जनरेटेड बाय सिंगल एलिमेंट ओके सपोज f of x हा तुमचा रिंग ऑफ पॉलिनॉमियल आहे ओके वेर f इज द field असेल if f of x is the ring of polynomial where f is the field then the nature of okay and suppose p of x is the any element of the f of x okay p of x हा कोणताही element आहे p of x is any element in capital F of x that is ring of polynomial so the nature of this idea p of x कसा असेल या p of x ने जनरेट झालेला एलिमेंट कसा असेल that is generated by p of x the ideal generated by this element p of x is in the form of p of x into g of x where g of x belongs to that f of x okay म्हणजेच कोणताही मी एक एलिमेंट सपोज q of x belongs to this p of x ideal generated by p of x okay suppose I am taken q of x belongs to this ideal so q of x is in the form of p of x into r of x काही पण for some r of x belongs to f of x okay सांगण्याचा उद्देश काय जर मी कोणताही एलिमेंट जर मी या आयडियल मधनं घेतला कोणत्या या आयडियल मध्ये तर त्याचं नेचर कसं असेल q of x is equal to p of x into r of x ओके याच्या मल्टिपल मध्ये
Yes, sir.
फॉर एक्झाम्पल ओके ह्याच्यापासून जनरेट झालेला पॉलिनॉमियल कसा असेल त्याचा फॉर्म x square plus 1 into suppose this is h of x for some h of x belongs to capital F of x. Capital F of x. Okay. Now look at here. If suppose 2x square plus 4. This element belongs to ideal generated by x square plus 2. Okay, x square generated by 2. Ideal generated by x square plus 2. So, okay, so this element we can write in the form of 2x square plus 4 is equal to 2 into x square plus 2. Okay, where h of x is the काय येईल तुमचा constant polynomial 2. This belongs to this f of x. Okay, म्हणजे मी कोणताही एलिमेंट आयडियल जनरेटेड बाय this polynomial, then we can write in the form of x square plus 2 into h of x. Okay, त्याचं नेचर सांगितलं आम्ही कसं असतो. आयडियल जनरेटेड बाय p of x. ओके, आता नीट लक्ष द्या. Ideal generated by p of x is always not equal to 0. Okay, that is, what is the meaning of this sentence? The ideal is not null ideal. Now, what is the meaning of not null ideal म्हणजे काय? तो not null ideal म्हणजे त्याच्यामध्ये हा सिंगलटन झिरो नाही आहे, त्याच्यामध्ये कोणता तरी एक एलिमेंट आहे. Why? Since we can write p of x into 1, which is equal to p of x. Okay, so which is belongs to ideal generated by p of x. Okay, at least या आयडियल मध्ये हा एक तरी एलिमेंट आहे, याचा अर्थ असा होतो. Okay, so hence ideal generated by p of x is always non-empty. Okay, any doubt?
No, sir.
No, sir.
No, sir.
Now tell me, what is the definition of maximal ideal? Definition of maximal ideal. What is the definition of maximal ideal? झालंय ना तुम्हाला हे? There does not exist,
Yes, sir.
there does not exist any proper ideal in between S and R. Okay, if suppose R is the commutative ring with unity and S is the ideal of R, then we say that S is the maximal ideal of R if there does not exist any ideal in between S and R. Okay, which is properly contained in N. याचा अर्थ काय? Which is sorry, S is properly contained in N is contained in R. Okay, या दोघांच्या मध्ये कोणताही आयडियल एक्झिस्ट व्हायला नको. जर आयडियल हा एक्झिस्ट झाला N, तर तो एक तर S ला कोइन्साइड होईल और तो काय
R ला coincide.
कोइन्साइड होईल. ओके, जर झाला असतं, hence we can say that S is the maximal ideal of R. Okay, for example, if R is equal to Z, ideal generated by 3Z, which is equal to काय आहे 0 plus minus 3 plus minus 6 up to so on. Okay, so 3Z which is contained in Z, या 3Z आणि Z मध्ये कोणताही आयडियल एक्झिस्ट होत नाही. ओके, होईल का कोणता एक?
No, sir.
आयडियल जनरेटेड बाय 3 which is equal to 3Z. ओके, या 3Z आणि Z मध्ये कंटेन होणारा, प्रॉपरली कंटेन होणारा, याच्यामध्ये कोणीही येणार नाही. ओके, सो लुक ॲट द डेफिनेशन. मॅक्झिमल आयडियल of a ring R. Okay, this is definition. A maximal ideal of a ring R is an ideal M different from R such that there is no proper ideal N of R. Okay, so what is the maximal ideal? The M हा काय तुमचा maximal ideal. Okay, which is different from R. ओके, एस इज नॉट इक्वल टू आर पाहिजे बरं का. And such that there is no proper ideal n of R properly containing m. Okay, so this is the definition of maximal ideal. So maximal ideal of a ring R is an ideal m different from R such that there is no proper ideal n of R properly containing m. म्हणजेच काय, m हा नॉट इक्वल टू आर पाहिजे आधी. ठीक आहे, डिफरंट फ्रॉम आर. म्हणजे तर तुम्ही म्हणताल जर m इज इक्वल टू आर असेल, या m च्या आणि r च्या मध्ये कोणी येत नाही, मग हा स्वतःलाच आर हा काय झाला, स्वतःच मॅक्झिमल आयडियल होतो असं म्हणायचं, असं म्हणताल तुम्ही. सो हेन्स here given as m is different from r. Okay, such that there is no proper ideal n of r. There no proper ideal of r properly containing m. म्हणजे हा तुमचा काय प्रॉपरली कंटेन पाहिजे कोणामध्ये, n मध्ये. m हा प्रॉपरली कंटेन्ड इन n which is contained in r. ओके, हा पण आयडियल आहे तुमचा. अशी कंडिशन एक्झिस्ट व्हायला नको. ओके, then we say that this m is maximal ideal of r. Okay, for example 3z is maximal in z. 5z is maximal in z. प्रत्येक प्राइम एलिमेंटनी जनरेट होणारा एलिमेंट काय असतो, आयडियल हा मॅक्सिमल आयडियल असतो. कोणाचा, झेडचा. ओके, सो दिस इज द डेफिनेशन ऑफ मॅक्सिमल आयडियल. या झेड मध्ये फक्त प्राइम एलिमेंट नाही बरं का. प्रत्येक वेळेस प्राइम एलिमेंटने असणारा हा मॅक्सिमल असेलच असं सांगता येत नाही. ओके, तो तुमच्या रिंगवर अवलंबून आहे. रिंग कसा आहे त्याच्यावर अवलंबून आहे. ओके, समजा या झेडला नुसता आय जरी गॉसियन एंट्री जरी केला, आय जॉईंट केला, तर लगेच मॅक्सिमम आयडियलची डेफिनेशन बदलते. ओके, त्याचे एक्झाम्पल आपण नंतर बघूया अजून काही. आणि नेक्स्ट डेफिनेशन इज प्राइम आयडियल. व्हॉट इज द डेफिनेशन ऑफ प्राइम आयडियल झालं नाही पण.
हो सर.
व्हॉट इज द डेफिनेशन ऑफ प्राइम आयडियल? an ideal n which is not equal to r. R ideal which is not equal to r, that is different from r पाहिजे in a commutative ring R is prime ideal. ओके, या n ला प्राइम आयडियल कधी म्हणायचं? इज प्राइम आयडियल इफ a into b belongs to n. जर दोघांचा प्रोडक्ट जर n मध्ये जात असेल, इट इम्प्लाइज either
A belongs to n or B belongs to n.
or b belongs to n. इतकीच आहे का डेफिनेशन?
n not equal to r.
a b belongs to r. ओके, प्रत्येक a b साठी. ओके, फॉर एक्झाम्पल r is equal to z, which is commutative ring with unity पण आहे, without zero divisor पण आहे, सगळंच आहे. ओके, 12 belongs to n. ओके, which is equal to समजा 3z. ओके, which is equal to generated by 3. आहे का नाही 12 याच्यामध्ये? प्लस मायनस 3 प्लस मायनस 6 प्लस मायनस 9 प्लस मायनस 12 म्हणजे प्लस 12 आहे. सो दिस इज a 12 is equal to 3 into 4 which is belongs to n. Okay, so this is a, this is b. So here a belongs to what? N, which is generated by 3z. Hence for a उदी बरं का, प्रत्येक ab साठी for all ab belongs to r. Okay, so here a is, a belongs to n, is ideal generated by 3 is prime ideal. कळत नसेल तर लक्ष द्या. जनरेटेड बाय 3 ला प्राइम का म्हणायचं? प्लस मायनस 0 प्लस मायनस 3 प्लस मायनस 6 प्लस मायनस 9 अप टू सो ऑन. त्याच्यातला कोणताही एलिमेंट घ्या. 21 belongs to generated by 3. So 21 we can write in the form of 7 into 3. So this is A, this is B. Okay, the 21 तुमचा that is A into B is generated by 3 मध्ये असेल. So here what we get? B belongs to 3 set. Okay, what is B? 3 belongs to ideal generated by 3. Hence, ideal generated by 3 is the prime ideal. Okay, any
Yes,
doubt?
sir.
इथे महत्वाचं काय हे कंडिशन ऑल ए बी हेच विसरतात सगळे एकासाठी नाही प्रत्येकासाठी ट्रू व्हायला पाहिजे ओके one theorem is there. The proof of the theorem we will see in the next lecture. So write down only statement. Yeah. If F is a field, if F is a field, then the ideal generated by P of X, which is not equal to null ideal, that is 0, of capital F of X, okay, is maximal. हा F दिलेला ideal maximal कधी असेल is maximal if and only if P of X is irreducible over F. Okay, what is the meaning of that sentence? If suppose this P of X, okay, ideal generated by P of X is the irreducible असेल तर तो हा irreducible असेल तर हा ideal कसा असतो maximal ideal. Okay, if and only if. Okay, implies and implied दोन्ही स्टेटमेंट करेक्ट कॉन्व्हर्स पण ट्रू होणार आहे जर हा P of X तर irreducible असेल त्या irreducible एलिमेंटनी जनरेट होणारा आयडियल हा कसा असतो मॅक्सिमल आयडियल. ओके, जर हा मॅक्सिमल असेल तर काय होणार P of X हा काय असेल irreducible. Okay, so this proof we see in the next lecture. Okay, any doubt up to here?
No, sir.
Okay, wait a minute.